Next video of 7.3, we're going to look at cofunction identities. And cofunctions we discussed back in chapter 5. And when we have an angle, open up to a certain point, so it's 30 degrees. So here's our angle at 30 degrees, and this point that comes off, that goes through this angle. We can come straight down, that'd be our y value, right? And this would be our x value from here to here. So sine of 30 degrees, and so this is a right angle. So sine of 30 is opposite over hypotenuse, right? So we'll say, oh, what if this is, say, is equal to 4, or let's say, actually, let's do 3 here, and this is equal to 4. So then we know this is 5. Okay, so sine is equal to y over hypotenuse, not over x, sorry, over the hypotenuse. So sine of 30 is 3 over 5. Well, if this is 90, this is 30, that means this one has to be 60, correct? So if we look at cosine of this angle, cosine of 60, that would also equal 3 over 5. So the idea of the cofunctions, right? These two have to add up to 90. So then we get these cofunctions, cosine of 90 degrees minus our angle will equal sine of that angle. So for instance, right, 90 minus 30 is 60, and cosine of 60 is the same as cosine of my angle, right, of this angle. This angle's 30. Okay, so that's one cofunction. Then we can write all the others. Sine of 90 minus theta, 90 degrees, right? These are all in degrees. You can switch them to radians by just doing pi over 2 for the 90, right? Because 90 is the same as pi over 2. Cosecant of 90 minus theta is equal to secant of theta. And then if I flip that, I would get secant of 90 minus theta would equal, and this all comes from your y over h and x over y, because right, this is your opposite side, this is your adjacent if we're going off of 30. But it would switch sides, right? If I was going off of 60, this would be adjacent instead of opposite, and this would be opposite. So that's why these kind of are cofunctions. That's why sine lines up with cosine, cosecant lines up with secant, and then cotangent will line up with tangent. And so those are these 6, 1, 2, 3, 1, 2, 3 here, these 2 here, and this one up here. So those are all our cofunctions. So we can use this just kind of like what we did in chapter 5. We use these as well, but we can use them here as identities. Okay, so we can use them as identities. So let's go ahead and practice a couple like this. So we want to find the value of theta or x that satisfies each following. So if cotangent of theta is equal to tangent of 25, then we can use this identity of cotangent of 90 minus our angle here. So cotangent of 90 minus the angle that we're given at 25 will equal tangent of 25. Right, because here's the formula. This was, in our formula, this was theta and theta, right? Even though we're answering for theta, so if you want to switch that instead of a theta here, you could use an x, whatever. So basically, you're just asking yourself, okay, since these are cofunctions, cotangent, tangent are cofunctions, basically, what plus 90 or 25 plus what equals 90? That's kind of what you're asking. 25 plus what is 90, or 90 minus your angle that you're given equals, what does that equal? So 90 minus 25, or what plus 25 equals 90? So that's 65. So cotangent of 65 is equal to tan of 25. And you can type this in your calculator, except for when you type cotangent of 65, you would have to do 1 over tan of 65 on your calculator, and then just hit 1, and then just hit tangent of 25, and you'd get the same answer. So our angle that we're looking for is 65. Here, cosine of negative 30 equals sine of 30. So here we can do sine of 90 minus our angle, which is a negative 30. So that's going to be addition there. So sine of 120 will equal sine of negative 30. Okay. Here, the last one, we're looking at cosecant secant. So secant of 90 minus the angle that we're given, but here we're in radians. So if you want to, you could change this 3/4 pi into degrees if you wanted to, or you can just switch the 90 to radians, which is pi halves. Then we're going to have to find common denominator, so 2 pi over 4 minus 3 pi over 4. So cosecant of 3/4 pi is the same as secant of negative 1/4 pi. So our angle is a negative 1/4 pi. Okay, so on page 654, look at numbers 33 and 37. So you can try these out on your own, and then you can watch the video if you need to. So basically 45 plus 2 times what angle will equal 90, right? This one's a little bit different, because before it just gave us an angle of tangent, and then it didn't even have this in here. So what we're going to have to do is, because normally it's tan of theta is equal to cotangent of 90 minus theta. So actually inside this parentheses needs to be 90 minus theta, not 45 plus 2 theta. So if we take this and we set it equal to each other, 90 minus theta equals 45 plus 2 theta. We can add theta to both sides, so then we have 3 theta. Plus 45 equals 90. And we can go ahead and subtract 45 on both sides. So we get 45 is equal to 3 theta divided by 3. So theta has to equal 15. And we can test that out. Tan of 15 is equal to cotangent 45 plus 2 times 15. So that's 30. So that's cotangent of 45 plus 30 is 75. So cotangent of 45 is the same as tangent of 15, because as you can see, these two, 15 and 75, add up to 90. So there's our theta for number 33. So this one was a little different. We can go ahead and look at number 37 now. So sine of 33 theta minus 15 degrees is equal to cosine of theta plus 25 degrees. That's 25 degrees. Okay, so we know from our identities that we have sine and cosine are cofunctions of each other. So sine and cosines are cofunctions of each other. So if we have sine of some angle, okay, all of this, okay, then it has to equal cosine of 90 minus whatever that is, right? Whatever that angle is. Well, my angle, the whole thing, is 3 theta minus 15. But what does cosine actually equal over here? It equals theta plus 25. Okay, so whenever I have sine of an angle, right, sine of some angle, let's use x, has to equal cosine, to be cofunctions, cosine 90 minus x, right? So that means sine of whatever I'm taking, the angle, but our angle is this 3 times an angle minus 15 degrees, right? And then I got to take 90 minus that, so I'm going to take 90 minus that. So that's our 90 minus x. And that's what cosine is supposed to be of. But cosine but cosine is this, but I need it to be 90 minus x, so I set it equal to each other. So I take my 90 minus x, which is this, 90 minus whatever the sine, whatever the angle of sine is, and set it equal to what we have inside of cosine here, set it equal to that. So now we can solve this, distribute that negative. Okay, we can, oh, that's theta. Now we can move our thetas over. Might as well deal with a positive theta. So we have 90 plus 15. I'm going to add here, so that's 105 is equal to 3 theta plus 25. So now I'm going to subtract 25. So that's 80 equals 3 theta. Divide by 3, divide by 3. Okay, well, let's actually make sure I added right here. Now, that is a 3, but this is actually going to be 4, right? So this is a 4, so this is a 4, so this is a 4. So theta equals 20 degrees. So kind of that's the advantage of having odd answers, right? Because then you can look up and say, oh, I was supposed to get, when I divided by 3, I looked at the answer and said, oh, it's supposed to be 20. So then I went back and said, okay, where did I make a mistake? Well, in my simple addition, right? That was 3. So that needed to be 4, 4, and then I get my 20. So there's my angle, 20. Okay, so that's it for this video.